When considering the inverse of a function, we must consider a special situation. That is say, for the original function, if it is a linear function, but here, if a not equal to 0, you will find its inverse of a function must be a function. But if a equals 0, that will say a equals 0, so the original function will become this expression. That will say y equals this constant. That will say y equals b. From the graph, we can figure out y equals b can be represented by this straight line. That will say this is the constant b, y equals b. This is the graph of the function, right? We can figure out this horizontal line y equals b should be a function because this green straight line can pass vertical line test. So in geometry, we can judge this relation is a function. In algebra, we can judge this relation is also a function because for every different x, we just have the only one y value to correspond with the x value. So this green straight line must be a function. Here, if we want to figure out the expression for the inverse of this original function, we need to use this x to replace this y. We use y to replace this x. Here, it is in uppercase, but in fact, we can use the lowercase to replace the uppercase. So x equals ay plus b. Then we can figure out x minus b equals ay. We can figure out y equals x minus b over a. But in fact, here we have known a equals 0, so a times y must be equal to 0. So x minus b equals 0. We can figure out x equals b. This expression in geometry, we know this expression can be represented by the vertical line. That is say, this x coordinate must be equal to b. This is a constant. So this red straight line is the graph of this relation. In geometry, we can figure out this straight line cannot pass vertical line test because just for this vertical line, you will find out this vertical line will overlap this relations graph. That is say, for the vertical line, we will have countless POIs between this vertical line and this straight line. That is say, the POI is not only one POI, so this red straight line cannot pass vertical line test. This is the geometry. But in algebra, we can judge x equals b. That will say, when x equals b, we will have countless y value to correspond with this x value. So for x value, we have countless y value. That will say it is not 1-to-1 relation. So in algebra, we can judge this relation is not a function. In geometry, we can judge it is not a function. So you must be careful if the original function is a horizontal line represented by this expression, that will say a equals 0, its inverse should be this vertical line, but this vertical line is not a function. It's not a function. It is just a relation. And further discussion, if you transform this expression to this expression, you will find out y equals x minus b over a. Here, a equals 0. That will say, in the position of the denominator, a equals 0. So this expression will be undefined. That you say y equals this expression undefined in this situation, that is, this expression will be a vertical line. This vertical line is not a function. It is just a vertical line. So let's summarize. The original function, if it is a linear function, but here a equals 0, its inverse of this original function will not be a function. The inverse of this function will be a relation, not a function.